Welcome back to this discussion on nested statements and scope. Now that you understand functions, it's time to discuss scope. When defining parameters outside and inside of functions, Python uses scope to understand what variable is being referred to inside of the function. This is best explained through example, so let's open up a Jupyter Notebook and see what we're talking about. Let's begin with a simple thought experiment. Imagine I define the variable x, and it will be a string called outside. Then I'm going to create a function called report. It's going to be just a function that takes in no parameters. And then inside this function, I will define a variable called x called inside. And then I'm going to return the object x. Now, what do you expect the result to be when I call report? Should it be the string outside or should it be the string inside? Well, if you run this, you get back inside. And intuitively, hopefully that makes sense, since we can see that x was reassigned inside the report function. However, what do you think will happen when I call print x? Will it be outside or inside? And if you guessed inside, this is where you're wrong. In fact, this reassignment is only happening for this function. It's not happening outside of the function. The reason we don't see this effect take place is because of something called scope. And the idea of scope in your code is very important to understand in order to properly assign and call variable names. In simple terms, the idea of scope can be described by three general rules. The first is that name assignments will create or change local names by default. And name references search at most 4 scopes. And the 4 scopes are local scope, enclosing scope, global scope, and then built-in scope. So this is also known as the LEGB rule. So L for local, E for enclosing, G for global, and B for built-in. So let's look at each level of these scopes to get an understanding of what we mean by them. We'll first start off with an example of local scope. So let's imagine I create that function again, report, and do this assignment. This is known as local scope because it's local to this actual function. So then if I say print x and I call report, I get back local. Now let's look at an example of enclosing. And remember that this occurs when a function is enclosed inside of another function. And these are called nested functions. You're not going to use them too much as you start out programming, but it is possible. So we will create a variable called x, and we'll say this is global level. Then we will create a function called enclosing, and it will say x is equal to enclosing level. And then inside of this enclosing function, I'm going to put in another function. And as I mentioned, when you're starting off learning about Python, you're not going to be doing functions inside of functions too often. This is really just to show you scope, or the concept of scope. So I will create a function called inside, and then inside this function, I will say print x, and then check out my indentation here. I will call the inside function inside enclosing. So now let's see what happens when I call enclosing. And before we run this, let's imagine what's going to happen here. I start off with x being reassigned at the global level. This is global level. Then I have the enclosing function. I reassign x to be enclosing level. Then I've defined this function inside of the enclosing function, and we can see that based off its indentation. And then I call inside the enclosing function. So when I run this, I get back enclosing level. So this is the next level after local, enclosing. So you can imagine that Python, when you finally call a variable name all the way inside x, it first looks locally. It says, is this x variable defined somewhere locally inside this function? If it doesn't find it, it goes up a level to enclosing. Is this variable x defined somewhere inside this enclosing function? And in fact, it is enclosing level, so that's what it chooses as the value of x. Now let's go ahead and discover the global level. So I'm going to delete this line that defines x at an enclosing level, and then the next level up to find x is the global level. So if I rerun this cell to redefine these two functions, and then I run enclosing, I get back this is global level. So again, we're going through the levels here: local, enclosing, global, and built-in. So we check out local first. Python says, well, where is the variable x defined? It looks locally, it can't find it. So then it looks inside an enclosing function, if there is one. There's not always an enclosing function, and says, well, x isn't defined here. So then it looks in the global namespace, and global namespace is basically defined as having no indentation. So it's not indented in any sort of function. It goes all the way to the left. And here we do find that x is globally defined, so that's what we choose as this global value. Now there are built-in. So built-in is one level above global. So if it still can't find it in a global assignment, it assumes that it's going to be a built-in function or keyword. And these are keywords such as len for length, sum, or list. And that's why it's so important that you don't reassign these basic terms that have built-in functionality and are part of Python, because you start messing up with the scope of Python. So that means if we can't find x at a local level, enclosing level, or global level, Python is going to try to see if it's a predefined built-in parameter in its code in Python. But if it's not, then finally, let's imagine that we say here we have y. If we run this and then call enclosing, it's going to say name error, name y is not defined. So that means it looked in all its levels. It looked in local scope, enclosing scope, it looked at global keywords, and then finally it checked everything that's built into Python, and it still cannot find y. So you end up getting this name error, y is not defined. So now that we've seen the levels, I quickly want to show one more example of global versus local, because those are really the main ones you're going to be having to deal with, understanding global scope versus local scope. So I'm going to create x over here and say this is global outside. Then I will create a simple function, and the function takes in x, and it's going to print x is, and then we're going to format x there. So notice what happens. If I call my func and I pass in x, it says x is global outside, because x has already been defined here globally. However, if later on inside this function I say redefined inside my func, and then I try to print out x again, and I run my func, it will say x is global outside, but by the time x comes here, Python is doing that search all over again. It first searches the local namespace, and it can find here that x has been defined locally, so it chooses that. It does that before it goes to search for an enclosing function or before it searches for a global assignment. So that's really LEGB, local, enclosing, global, and built-in. It's just the order that Python searches for variable names. So this allows Python to effectively search the namespace. Now there may be an occasion where, for whatever reason, you specifically want to overwrite the global variable inside of a function. In order to do that, you can actually use the global keyword before the variable to indicate that you wanted to, quote, grab the global variable. Keep in mind, this is generally not recommended, and you should try your best to avoid this until you become more experienced with Python, because it becomes really easy to accidentally create errors this way by overriding variables in one part of your script that affect the script in a completely different part. So we're going to show you how you can use the global keyword, but if you're just a beginner in Python, you should really avoid using it. So here I see x is global outside, I print out x is blah, 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 I redefine x, and then I print out x. So if I run this cell again, notice I get x is global outside, redefined in my func, and if I were to type x again, hopefully by now you've realized it will be global outside, because this reassignment is only in the scope of this function. It doesn't actually have scope to global levels. So this reassignment only happens inside the scope locally. So what does that mean? Let's imagine that I wanted to actually affect the global variable and overwrite it inside of my function. So the way you can use the global keyword is before you ever use the variable inside of a function, you're going to say global and then the name of the variable. And that will tell Python, go ahead and reach out to find this variable in the global namespace, and any changes you do locally will affect this global variable. However, when you're using the global keyword, you can't also have it be a parameter name inside your function. In fact, if you try to run this code, Python will warn you of that error. So we run this and it says, syntax error, the name x is parameter and global. And that just doesn't make sense with Python. It can't have it both ways of dealing with a global variable x, but also having some sort of parameter being passed in of the same name. It will get confused trying to figure out which one of these two to use. So we'll go ahead and remove it here from the parameter, and our function just won't accept the parameter. Instead, what it's going to do is it reaches out to the global namespace to find global outside. It prints it out, it reassigns it, and remember we're reassigning now the global x, and then it's going to print it out again. So let's run this, and now Python has no problems. And then when I call myfunc, notice I'm not passing in anything anymore. I get back x is global outside, redefined inside of my function. And now, unlike last time, when I say print x, x at a global level has now been redefined to be this string. And the only way that can happen is if you specifically call the global keyword in front of that variable. And as we previously mentioned, this is really not recommended for beginners, and in general is just poor programming practice unless you have a very specific use case for it and you know very well why you're using global. And again, the reason for that is it becomes really easy to induce bugs somewhere else in your code because you may have another function somewhere in your script that is making a grab to some global variable, assuming it's not being played around with or reassigned in some other function, maybe hundreds of lines down. So that's why you want to generally avoid this global keyword. We show it to you now so you're aware of it in case you ever do need to use it, but in general, try to avoid it. Instead, use parameters that are passed in, and if you do need to affect the global variable, instead of printing it, what you should do is return x, and you're going to be returning the local x. So let's see what happens there. So we'll say x is global outside, myfunc, we'll pass in x here, it's going to print format x, it's going to redefine it, and then it's going to return it. And that's really what we want to do instead of using that global keyword. So then when you run this, and you pass an x, and then have a result, it goes ahead and says it prints x is global outside, but then your result is now redefined inside my function. And this is a nice way of having it both ways, because if you call x, it's still global outside, but you've been able to adapt any changes you want to it and return it and save it as some sort of other variable. All right, that's it for nested statements and scope. Hopefully this was clear to you as far as how to deal with namespace in Python. We'll see you at the next lesson, Recruit.